Welcome to Tech Bytes and News, your daily roundup of articles featured in Hacker News. Today, we're diving deep into the fascinating world of cloud virtualization, specifically exploring the inner workings of Red Hat, AWS Firecracker, Ubicloud, and AWS Nitro architectures. It's a complex topic, but we'll break it down step by step. Get ready.
I'm eager to hear this. The evolution of virtualization is mind-blowing. So, what's the core challenge this blog post addresses?
Exactly. The core issue is that understanding modern VM technology is incredibly difficult. It's not just about one component. It's a complex interplay of dozens of Linux projects, all working together to achieve operational and security isolation across CPU, memory, disk, and network. Think of it like a highly intricate clock mechanism. Each gear needs to mesh perfectly.
Right, a multi-dimensional puzzle. So how does the blog approach this complexity?
The authors meticulously analyzed various architectures, creating reference designs for Red Hat, AWS Firecracker, Ubicloud, and AWS Nitro. They essentially reverse-engineered these systems, breaking down the complex interactions into digestible pieces. It's a fantastic resource for anyone wanting a deeper understanding.
Brilliant. Let's start with Red Hat. What's their approach?
Red Hat uses a combination of KVM, kernel-based virtual machine, QEMU, quick emulator, and libvirt. KVM handles the core virtualization within the kernel, QEMU emulates hardware devices, and libvirt acts as a jailer, enhancing security by restricting QEMU's access to system resources. They also leverage C groups for operational isolation and NF tables for network security.
So QEMU is the virtual machine monitor, VMM, in this case, right? And libvirt adds a crucial security layer. Interesting.
Precisely. Now let's contrast that with AWS Firecracker. It's a much more lightweight approach, optimized for serverless workloads. They still use KVM, but replace QEMU with their own custom VMM written in Rust, a much safer language.
Rust's memory safety is a huge advantage in this context, reducing the attack surface. What other key differences are there?
Firecracker uses a simpler approach to resource management, implementing its own rate limiting instead of relying on C groups. It also prioritizes security by using block devices instead of file system pass-through, minimizing the complexity and potential vulnerabilities. And instead of libvirt, it uses a custom jailer with seccomp BPF for syscall filtering.
Fascinating. So Ubicloud's architecture is similar to Firecracker, but with some key distinctions?
Yes. Ubicloud uses KVM and a custom VMM called Cloud Hypervisor, CH, also written in Rust, and heavily inspired by Firecracker. However, CH is more general purpose, supporting both Linux and Windows, though Windows support is still untested. They also use SSH for communication between the control and data planes, unlike Firecracker's REST API. The security model is very similar, though.
I see. And finally, AWS Nitro? That's a completely different beast, isn't it?
Absolutely. AWS Nitro represents a significant shift towards hardware offloading. Instead of relying heavily on software-based virtualization, they use specialized hardware cards for network and storage, dramatically improving performance and reducing the load on the host's CPU. This allows them to run a much simpler hypervisor.
So it's a trade-off. Increased hardware complexity for significantly improved performance and efficiency. A very interesting evolution.
Exactly. The blog post concludes by highlighting the remarkable progress in both hardware and open-source software that has made these sophisticated virtualization architectures possible. From dual-core processors to 64-plus core servers, and the rise of Virtio for device virtualization, the landscape has changed dramatically.
It's a testament to the power of open source and the relentless drive for innovation in the cloud computing space. A truly impressive journey.
Absolutely. And that's a wrap for today's Tech Bytes and News. Thanks for joining us on this deep dive into the world of cloud virtualization. We hope you found it as insightful as we did. Goodbye, and have a great day.
Bye-bye.